Dear students, welcome to the lecture series of Object-Oriented Programming. In this lecture, we are going to see the member function templates with syntax. Example, we will also see the non-type template arguments. At the end of this lecture, you will be able to use member function templates. Member function templates. Why do we need it? When we create a class template, we define all the member functions as inline, which is not at all necessary. We can define the member functions outside the class as well. Member functions of the template classes are parameterized by the type argument to their template classes. So, these functions must be defined by the function templates. If you observe the syntax here, I have here the template statement, and here I have return type followed by the class name followed by the type T. Here we are having the generic type followed by the scope resolution operator followed by the function name with the argument list, and here it is a body of function. So as we declare the member function outside the class, in the same way we have declared here the member function template, only the difference is here we have the type as a generic data type and here we have the template statement. Let us see a simple example how to declare the member function templates. Here we have a class template. Here we have class vector with a parameter with generic type T, and inside that we have the data members, private data members, that is V, and size. Size is of type integer whereas V is type T vector, and here we have the member functions. Here we have our parameterized constructor which has the parameter as integer m. Here we have another constructor which has a type t, which is passed as an argument over here, and here we have the operator function with type t. And now these are the three member functions of my class vector, and if you want to declare those member functions outside the class as the member function template, then you can simply write the template statement with vector t, that is the name of my class, followed by the generic type t, followed by the scope resolution operator, followed by the vector with the argument list, that is m in this case. And this is the function definition. If you want to declare if you want to define another member function as a member function templates outside the class, which is vector t star a, you can have the definition like this, that is again we have to write the template statement, then vector t followed by the scope resolution operator followed by vector which is the name of member function, and here I have the argument list. And if you observe this operator function, again in the same way, here the return type is of t, then same I have written here, followed by the name of a class, that is vector, followed by t data type, and followed by the scope resolution operator followed by the operator which is my function, and this is the argument list. So if you observe, everything is same as the function template, only the difference is here we have to indicate that respective function belongs to that class. Okay, that respective function belongs to that class vector, and using the scope resolution operator we can do that. So this is the way we can have the member function templates outside the class definition. Let us see the non-type template arguments. As we have already learned that template can have multiple arguments. With that multiple arguments, we can also have the templates with non-type arguments. We can use the arguments such as strings, function name, constant expressions, and built-in types instead of the template argument. Here is the example. Here in the template statement, we have class T as our template argument, but with that we have non-type template argument, that is integer size. So we can do that also. And here we have the class array, and here a of size, a of some size, that is a automatic array we can create of any type, any generic type. T here is declared as a any data type. Okay, and if you observe this complete example, then this template supplies the size of the array as an argument. Okay, size of the array as an argument, and this implies that the size of array is known to the compiler at the compile time. That means here we have not specified any size like 10, 20. So size will be known to the compiler at the compile time. The arguments must be specified whenever a template class is created. That means here in whenever the template class is created, that argument must be specified in the template function, sorry, in the template statement. Here are some examples. Here we have the array, here we have the integer which is of 10, size 10, and object we have created as a a1. Here we have another object, that is a2. Okay, and it is with respect to this array example. This is the template class, and we have created the objects of that template class. Okay, so when we create the object of that template class, of course we have to specify the arguments, uh, arguments at the place of size here. Okay, so if you match this template class t comma integer size, so here we have to declare the size in the declaration in the at the time of creating the object, and here we have to specify the data type which we want to create, which type of array we want to create. So here we have the first array which has a size 10, which is of integer type. Okay, and the object is a1. Here we have created a2, which is an array of type float, and it has 5 values, 5 elements, and we have a3 which has size 20, and which is of character type. That means it is a string of size 20. So the argument, when we declare this non-type template argument, okay, at the time of uh, object creation, the arguments must be specified. Okay, when the template class is created, when the object of that respective template class is created. So this is how we can use the non-type template arguments. I hope you have understood the member function templates as well as non-type template arguments. So we'll meet in the next lecture. Thank you. Happy learning.